Well, this is pretty easy. It's ln of v minus vt minus the ln of negative vt. Well, if you take the natural log of one thing minus the natural log of the other, it's the same as dividing them. So you're going to end up with the ln of v minus vt over negative vt. Again, that equals negative k times m times t. I'm going to actually reverse this because I have a negative here to get rid of it. Multiply both sides by -1. I'll get the ln of the terminal velocity minus the velocity over the terminal velocity equals negative kmt. Well, the only way to clear out a natural log is by taking each thing to the e power. So e to the ln of vt minus v over vt is going to equal e to the negative k over m times t. And that's right. This becomes vt minus v over vt equals e to the negative kt over m. I multiply both sides by terminal velocity. I have vt minus v equals vt e to the minus kt to the m. I move this to the other side. I have negative v equals negative vt plus vt, e to the minus kt over m. Multiply both sides by -1. I get v equals vt minus vt e to the minus k over m. And I factor out a vt here. 1 minus e to the negative kt over m. kt over m. Okay. And let's see what this means. I mean, we got this expression, whoop-de-doo. Let's actually see what it means. What it means is that when this is 0, like let's take a look. Let's look at some specific times. When time equals 0, this term here becomes e to the 0 or 1. And that means that we're going to have a velocity of vt 1 minus that. That's going to be 0. Well, we like that, don't we? When t is gigantic, we're going to have v equals vt 1 minus e to the negative gigantic number. Which is going to be 1. Or 0, I'm sorry. Okay. So that means that we're going to end up with v equals vt, our terminal velocity. It's exactly what we thought we should get. And in the middle, it's just going to vary depending on how much there is. I know this is a ginormously difficult idea. I'm not going to pretend like it's easy. Okay. But this derivation is really important. There's actually a way to work it forward. And I'm going to do that real quick. We know acceleration is dv dt. So if I take this thing up here and take the derivative of it with respect to time, I'm going to actually separate it out here. And I'm going to have a equals vt minus vt e negative km, or t, sorry, over m. So, and that's dv dt. So I'm going to take both these with respect to time. This is just a constant, it goes away. Okay. Minus vt, and we got to take these things out because it's going to be negative k over m e to the minus kt over m. Because remember, the derivative of e to the x is e to the x, but if you have something in here, you have to take the derivative of that too. So we're going to have vt k over m e to the negative kt over m. That is a. Okay. But remember, vt equals mg over k. If we plug that in here, we get that mg over k times k over m equals, or no, e to the minus kt over m. Well, this goes away, those go away, and you get g e to the negative kt over m. And if you look, that works out nicely too, because at t equals 0, a is going to be g times e to the 0, or negative 0, which is just g. That's what we wanted. And if t equals gigantic, again, compared to the constants, then a is going to equal g times e to the negative giant number, which is going to be 0. Again, we're going to have terminal velocity. So that actually matches. We can work backwards to find a position one, and I'm going to do that. I don't know if quick is the right word, but it should work. Yeah. Our last step is to find the position function as a function of time. And we know that y as a function of time is just going to be the integral of v dt. And you can see this is just going to be kind of a mess. 0 to t of vt minus vt e to the negative kt over m with respect to time. Well, at least this term is easy. Okay. We know it's going to be vt, or vt, sorry, times time. Okay, minus the integral of vt e to the negative kt over m dt. Well, again, the integral of e to the x dx is just e to the x, but it's a little bit more complicated, you know, because if it's e to the u du that you're taking it up, it's going to be e to the u divided by u. Okay. So that will make that slightly more complicated. We'll take the v to the t out, I guess. So it's the side, or separate it. So we're going to have vt minus, now we're going to actually take the integral of that. It's going to be e minus k to the t to the m over minus k over m, all times vt. Okay. And then we can move it around. So we're going to have m over, well, first it's going to turn this into a plus vtt plus m over k times vt e to the negative kt over m. Okay, Good. So we're going to have y equals vt times t plus mvt over k e to the negative kt over m. And then I think your book actually goes through and actually like factors stuff out. They say it's t plus m over k e to the negative kt over m. Okay. Yep. Good. And again, this is the expression. I'm putting a cloud around it. A student once told me that if I put a cloud around something, that makes it correct. That's helpful. All right, that's the whole derivation. Whoa, I know it's a lot. Okay. Watch this several times till you understand what happens. And you have one problem tonight. I think it's like 5.100. And you'll need to apply what you know from this. So I wish you a lot of luck.